Now let's talk about derivatives. And derivatives are a really important part of calculus that you guys are going to be using a lot. So what is a derivative? A derivative is the slope of the tangent line to a function at a certain point. So let's just say we have this function, f of x, and we have a point on this function. The derivative at that point, let's say this is x equals 1, the derivative at x equals 1 is simply the slope of this tangent line. So f of x is a function, and the derivative of f of x, also called f prime of x, because we're going to see that notation a lot, is a function. So the derivative is a function, and it measures the slope of the tangent line to your original function. So we know how to find the slope of a tangent line to a function at some point, let's call it a. We can use limit notation to find that. And there are two basic formulas that you're going to want to memorize. And the first one is the limit as x approaches some value a, and a is going to be the point at which you're evaluating the derivative. So in our case right here, a would be 1. So as x is approaching a, and it's going to be the function at that point x minus the function at the point a over x minus a. So let's try and visualize this. So x is getting closer and closer and closer to a. So f of x and f of a are going to be very, very similar, but not the same. And so is x and a on the bottom. So over here we have this, pretty much it's a change in y, and over here we have a change in x, since x and a are both x values and f of x are y values on our graph. So what we're doing is we're pretty much zooming into this point and having a tiny, tiny change in x and a tiny, tiny change in y, and we get to a point where our function, even though it's curved, once we zoom in enough, it'll look linear, and that's where we evaluate it at the limit, where it is linear, and that'll give us the slope of that tangent line at that point a. So this is the slope of the tangent line at a. So let's look at one more equation that you guys are going to want to memorize, which is the limit as h approaches 0 of f of a plus h minus f of a all over h. So let's try to understand what this means. We have this number h, and it's getting really, really close to 0. So f of a plus h is going to be very, very close to f of a. It's going to be a bit different since h isn't exactly 0. It's approaching 0. So we have a tiny, tiny change in y, and then our change in x is pretty much just going to be h. And h is getting really, really small. So once again, we have this tiny change in y over some tiny, tiny change in x. And that's what we know as a slope. And once again, since it's very tiny, it's kind of like we're zooming in into the graph and finding the tangent line. We're zooming in enough to where this graph becomes linear. So that's a way to find the slope of the tangent line at some point a. And that's not what we're going to want to do all the time. Sometimes we want to find the equation of the derivative. Since the derivative, it's a function. It's a function, and it changes as x changes. The slope at this point at x equals 1 is different than the slope at x equals 0. I mean, clearly the slopes aren't the same. The slopes of the tangent lines aren't the same. So we want to find an equation or a function that describes the slope of the tangent lines of our initial function. And to do that, we're simply just going to use the second definition, the second limit equation, and instead of using a to find the slope of tangent line at some point a, we're simply going to use x as our variable, and that'll give us the derivative, the slope of the tangent line at any point x. So the derivative at any x, or at x, is going to be, well, we're just going to use that same second equation, and instead of a, we're going to have x plus h. And instead of a, we're going to have f of x all over h. And in the next couple videos, we'll be using this to actually evaluate derivatives. But these three equations are definitely going to be useful. And you definitely are going to want to memorize them and memorize what each part means. What's the significance of x, a, and h. And we'll be using that in the next couple of videos. And that's it.